Hey class, this is the seventh and final video in the stoichiometry series. And in this last video, we're going to learn how to convert moles to atoms. Now, moles to atoms is a simple one-step conversion as long as you have moles. But you have to have moles. You can't convert to atoms from grams, liters, or any other nonsense. Now, first off, you have to understand this is a simple one-step calculation, but we have to be sure and confident from what we've learned so far. Now, this question asks, how many atoms are in 12.6 moles of H2SO4, or sulfuric acid? Well, start off with the conversion factor. And for all atom questions, atom or molecule conversions, we're going to use Avogadro's number, which equals 1 mole of any substance is 6.02 times 10 to the 23rd atoms. You'll use this in every calculation, whether you're going from atoms to moles, or in this case, to atoms. So, the question asks us how many atoms. We're going to start off with what we want, which is question mark atoms of H2SO4. Now, what are we given? Luckily, we're given moles, so we don't even have to convert to moles. 12.6 moles of H2SO4. Now, again, we're going to use railroad technique helps us out again. 12.6 moles of H2SO4, draw your railroad track, railroad tie, over 1. Then you're looking for atoms, so you want moles to cancel. So we're going to say 1 mole of H2SO4 is equal to Avogadro's number, 6.02 times 10 to the 23rd atoms. Now, at this point, you're going to want to cancel out your moles. The bottom is just 1, so we can disregard that. And now is where you need a calculator. You're going to take your calculator, and remember, this is the simplest, easiest way to do it without making mistakes. You're going to say 12.6 times, open parentheses, 6.02 EE. So you're going to hit the EE button 1 time. 23. So let me write that down for you. 12.6 times, open parentheses, 6.02 EE 23. Now remember, you just hit this once. Now, after you do that, hit enter, and in this case, we're going to get 7.5852 times 10 to the 24th. We've got 1 decimal in our question, so we're going to round this to 1 decimal. Round to that 5, that 8's going to make it go up. We're going to get, for a final answer, 7.6 times 10 to the 24th atoms of H2SO4. Now, we can actually take this a step further and move on to a more complicated problem. So, for example, how many atoms are in 116.4 grams of lithium phosphide? So, we're going to use the same conversion, Avogadro's number, except this time we don't have moles, we have to get to moles. Now, how do we get to moles? From grams, we have to find the molar mass. It turns out lithium, which we have 3 of, has a molar mass of 6.941. But we're going to multiply that by 3 because we have 3 particles. So 6.941 times 3 gives us 20.823. I'm going to put a little line through that 6941 so we don't get confused. Now, plus phosphorus, which we just have 1 phosphorus, so that makes for an easy time. Phosphorus is 30.974. Now, we're going to add these 2 up. Is 51.797. And remember our units, it's grams per mole. Now, to get to atoms, we have to get moles. So let's first start off with what we want. Question mark, atoms of lithium phosphide, excuse me. What we're given, 116.4 grams of lithium phosphide. Now we already know how to do this. Grams to moles. Draw a railroad track out. Railroad tie over 1. We want grams to cancel out, so we need grams on bottom. 51.797 grams of lithium phosphide is 1 mole of lithium phosphide. Next step, cancel out your grams. Multiply straight across. 116.4 over 51.797. Now we're going to do that simple division to find out how many moles we have. So 116.4 divided by 51.797 gives us 2.24723. in our unit is moles of lithium phosphide. Now we have moles, we can find atoms. Start off with what we calculated, moles. So 2.24723 moles of lithium phosphide. Railroad track, railroad tie over 1. We want atoms, so we need moles on bottom. So 1 mole of lithium phosphide is Avogadro's number again. 6.02 times 10 to the 23rd atoms of lithium phosphide. Cancel out your units, so in this case, moles, they're gone. The bottom, 1 times 1 is 1, so we're going to ignore that. And then we're going to multiply straight across. So, take our moles, 2.24723, times, open parentheses, 6.02 EE, we're going to hit that button one time, and then 23, close parentheses. And that's going to give us 1.35 284 times 10 to the 24th atoms. How many decimal points were in our original question? Just 1. So we're going to round that. 3 is going to go up to 1.4 times 10 to the 24th atoms of lithium phosphide. So you can see it's just one extra step on top of what we've already learned. The key to this is to not get mixed up on where to put what. If you want atoms, you need atoms on top, you need moles to cancel. If they gave you the atoms, you'd need atoms on bottom and moles on top so that your atoms would cancel. Then you'd have 2 scientific notation numbers to divide by. Either way, don't get mixed up. Make sure what you don't want is canceling out. Make sure what you do want is on top. Thanks, guys.